Hello, I am Basarir and I am one of the authors of Developing Architectural Detailing Skill, a Self-Learning Method. I am also a research assistant at Mimar Sinan Fine Arts University, and I have got a research interest in architectural detailing and product development, especially on facade systems. The other author of this research is Assistant Professor Dr. Ömer Şükrü Deniz from Mimar Sinan Fine Arts University. Architectural detailing is a key skill of an architect at any level, but the scope of architectural detailing is so broad and dynamic that many architects endeavor to develop detailing skills throughout their careers, often with the way of self-learning. Learning anything by yourself can be a very rewarding experience. However, self-learners need to take initiative in all aspects of learning, diagnosing learning needs, formulating learning goals, identifying learning resources, extracting knowledge from resources, and evaluating learning outcomes. Extracting knowledge and providing the targeted outcomes from resources without using a specific method is quite challenging and also prolongs the skill development process. To overcome these challenges, we have sought solutions for systematic and target-driven knowledge extraction from the self-learning resources. For a systematical and target-driven knowledge extraction, a method or a procedure with defined phases, goals, and outcomes is needed. Since the self-learning resources are so extensive, we also limited this to a reliable resource: constructed project detail drawings. So the aim of this study is to reveal a self-learning method for architectural detailing through a widely benefited teaching method, project analysis, namely the case study. The scope of the study was shaped by identifying what could be learned from the project analysis. Designing a detail depends on many factors, such as human factors, constructability issues, time, and finance. When we analyze the details of a project, we see only one of the solutions that can achieve a specific purpose. Learners may not fully understand the mindset behind selection of a building product or a detailing technique. The functioning of the detailing process and the logic behind the decisions are made cannot be learned. So, what can we learn from the analysis of a constructed detail? It can be learned which building products are used to achieve specific purposes and how these building products are combined and connected to form a whole that works in harmony. The research was conducted based on 4 steps, starting with a comprehensive literature review of detailed design process, self-learning, case study research method, and reverse engineering from product design. In the second step, a preliminary analysis method was generated through this literature review. Then, it was applied by undergraduate architecture students within the scope of the course Detailed Design 1, given at Mimar Sinan Fine Arts University by the authors. By the application test, the method was evaluated in terms of functionality and ease of application. In the last step of the research, the method was refined based on the data obtained from the application test. The project analysis method is outlined with 4 phases: defining the design context, defining the building products, defining functions and joining methods of the building products, and functional analysis of the detail. Each phase serves a specific purpose and has defined outputs. To ease and standardize the analysis, checklists and templates are integrated into phases, proposed to be used by an architect at any level of detailing expertise. It's recommended to use the method sequentially, especially for those who have little experience in detail design. Application activities and learning outcomes of each phase are explained in this presentation. Before starting to use the method, learners must provide the pre-requirements, which are diagnosing learning needs and choosing adequate learning materials. The learning need can be diversified as learning a new technology, construction system, building product, or detail pattern. Then an appropriate learning material should be selected that can meet the learning need. Ideal learning materials, which are detailed drawings of a constructed project, should include project data with photographs, adequate documentation and drawings, at least 1 to 20 scale drawings with defined building products. I should mention that the content of pre-requirements often depends on the learner's detailing expertise. Now it's time to talk about the phases of the project analysis method. Application activities and learning outcomes of each phase are explained in the following slides. The aim of the first phase is to determine the design factors of the project and the detail to be analyzed in general terms. Understanding the detail context is important for understanding detailing logic, as these detailed design decisions are strongly tied to the design context. This phase consists of 3 steps. First one is defining project data, function, location, construction year, natural and built environment characteristics, and so on. In the other steps, project design factors and detailed design factors are defined, respectively. A design factors checklist with 23 criteria was generated for this phase. The most important design factor for analysis is function. However, the more information available on these criteria, the better defined the design context. The purpose of the second phase is to recognize building products and to increase building product knowledge. Published drawings are scaled and converted into measured 2- or 3-dimensional drawings in a computer-aided design and drafting software. This phase also helps those who have little experience in detailed drawing to learn the detailed drawing standards. Information about building products is obtained from annotations or hatches of the drawings. If there is a building product unfamiliar to the learner, market research should be conducted to identify the characteristics of the product. Learners who have little experience with detailed drawings often have a hard time reading them. The 2-dimensional nature of detailed drawings can make it difficult to distinguish what is drawn in plan versus what is drawn in section or elevation. For this reason, identical products are colored with identical colors, and the position of the product and its relations with other building products are followed in different drawings. The aim of the third phase is to determine the functions and joining methods of the building products. It's achieved through reverse engineering conception. A hypothetical disassembly is performed starting from the parameters of the detail. One building product is removed from the system at a time, and these questions are asked to define the joining method, which product it is connected to, and how it is connected to these products. With this method, we also define the assembly sequence from backwards. Likewise, when we remove a product from the system, the missing function defines the function of the product. Implementing this phase can be confusing for novice users. Therefore, common joining methods are provided as a checklist. Also, DIN standard for manufacturing processes, joining, can be used in determining the joining method. A sun shading panel is analyzed here as an example. The same sun shading panel is analyzed for the functions of its building products, and examples of common functions of building products are provided, such as joining, insulating, surfacing, load-bearing, and so on. The aim of the last phase, phase 4, is to determine how the detail patterns are used to perform the functions of the detail. Thus, different usage areas of detail patterns will be learned. There are 5 modules of detail patterns adapted from Allen and Rand: controlling water, water vapor, air, heat flow, and sound. Application of these modules are need-based and non-sequential. Basically, it's investigated whether the detail patterns that can be applied to perform a certain function are used, and if so, how they're applied. On the right side, detail patterns for controlling water, water vapor, and air are given. And on the left side, there is a terrace floor finish facade panel connection section detail. Let's look for detail patterns of controlling water. We can easily identify some detail patterns at first glance. Here on the right side, detail patterns for controlling heat flow and sound are shown. And thermal insulation and thermal break patterns were applied to the details. The application test of the method provided us with an insight into what might be encountered in practice. So here are some suggestions for its application. Don't proceed to the detail analysis without examining the context of the design, and don't make assumptions about undefined building products. Identifying what you don't know is also a form of learning outcome, so note down the issues you cannot resolve for further studies. And analyze complex details by breaking them into sub-assemblies. The method has many strengths. It's reliable, results are reproducible, phases, checklists, templates, and patterns ease its application, which reduces the struggles of self-learning approach. It's thought-provoking and ensures its users a keen eye for evaluating architectural details. There are some limitations of the method for sure. Learning outcomes cannot be isolated from the learning resources and level of expertise of the learners. It is still open for improvement and expansion, especially on detail patterns. This is how I summarize our research on this subject. Thank you for listening. Please don't hesitate to contact me if you have any question or contribution on this subject.